Hello everyone, welcome back to my channel. Today is day 22 of our 100 days of DevOps, and today we are going to begin with the second phase of our journey. So the first phase of our journey was we covered the core foundations, where with 21 days, that's 3 weeks, we covered everything we need to know and understand about Linux. We covered networking, we covered version control, we covered YAML, and yesterday we looked at Nginx. So the videos are on my YouTube channel. If you've not seen them, I would implore that you go and watch all of them, because like I always say, each day is layered on whatever we learned the previous day. So to have an understanding of today, you have to go and see the previous videos, so that we take everything step by step and you don't miss any part, because it's really going to be beneficial to you. And if you're seeing this channel for the first time, so what we are trying to achieve here is that we are trying to cover the core foundations of DevOps, do hands-on and help you understand everything about DevOps in 100 days. And we've broken this journey into about 6 to 7 phases. We just completed the phase 1, which is understanding the core foundation, and then we're moving to phase 2. So if it is something that you feel that resonates with you, that you like, or you want, or you know somebody who is interested in also learning DevOps, you can share the channel with them. You can also subscribe to the channel, like the videos, and most importantly, turn on your notification bell, so that whenever I upload any new content, you're able to get it as soon as it is uploaded. So like I said, today we are going to begin with the phase 2 of our journey. So this is the phase 1, where I already said we covered everything about Linux, networking, version control, YAML, as well as Nginx. So we are going straight to phase 2, and what we are going to cover in phase 2 is containers and CI/CD. So we're going to learn about containers and CI/CD pipelines. So we'll talk about Docker images, Docker Compose, GitHub Actions, and Jenkins for CI/CD. So without wasting much time, we're going to go into what we have for today. Today will be an introduction, because like I always say, it is good for us to understand why things are the way they are, what brought about all these technologies, and understand how they work under the hood. Because it's good if we understand that, then we're able to get a very good foundation, a very good knowledge about it. Because when it comes to issue of troubleshooting, you can't troubleshoot something that you don't understand. So what if we run into an instance? What if we run into a problem with maybe a container or an image? How do we know where to go and what to do if we don't even understand how things work under the hood? So we're going to do I'll try to be elaborate with my explanations today. At the same time, I won't really take so much time. I would try to explain what you need to know, and it's going to be at least sufficient for us going into this next 20 days. So whatever thing I don't explain now, as we encounter them, I will be making reference to them. I will also be explaining them. So, but today we are going to cover 4 things. We are going to cover why containers, we'll cover Docker lifecycle, we'll cover Docker architecture, and we'll set up Docker on our virtual machine. So, promises to be an interesting session. So, we are going to dive right in. So, why containers? But before we even start to ask questions on why containers, we need to go back in time. Before containers, there was virtualization, because virtualization gave rise to containers. And then before virtualization, there was just bare metal. So let's go back to the basis. So imagine that you have let me just copy this. So imagine that you have 3 applications. What's usually done before? You want to run 3 applications, you have to go and get 3 servers. Say you want to run a Node.js application, a Python application, you have to go and get 3 servers, and then you run each application on that server. But the issue now is that to get a server is not cheap. Get a server is expensive. And then for the fact that you get a server and very expensive and you can only run one application on it, that is a limiting factor. There is no room for flexibility. Secondly, most times there's always resource wastage in the sense that your application never really uses all the resources that is available in your server. So it just uses, let's say, for example, you get a server that has 100 gig of RAM and 100 CPU. So your application never really uses these resources. So the application might just require, your application might just require, say, maybe let's say it requires like 40 gig RAM and 40 gig RAM and let's say 6 CPUs. So if your application is using 40 gig RAM and 6 CPUs, so what happens to the remaining 60 gig RAM and what happens to the remaining 94 CPUs? It becomes a waste. So technology advanced and the concept of virtualization came into play. So now with virtualization, what happens is that, let me delete this. You remove this and remove this. You have one physical system. Make this white. Okay. So you have one physical system, and on your physical host, you install what is called a hypervisor. I'm sure that if you've been following these sessions, now you will know what a hypervisor is. Because basically, what I'm running my virtual machine on is what we call a hypervisor. So a hypervisor helps you run different different virtual machines on your physical host. You can see here I have 2 Ubuntu servers and I have 1 Red Hat server. So yes, so what happens is that you install what we call a hypervisor. On my very first video, I mentioned what a hypervisor is. So with a hypervisor, you can now decide that, okay, I want to run different operating system. So you have your Linux operating system, you have your Windows operating system, just and like that. So you can have several operating systems on one physical host, and then you now install your app on each of these hypervisors, on each of these virtual machines rather. So let's say app. So you have your app here. So now you have your app installed on each of these virtual machine, which is on your hypervisor. So that way you don't have so much memory usage. So each of these hypervisors, or each of these VM rather, they act like they are your main, they are like your main, what will I call it? Your main server. So basically, it does not know that this VM does not know that it is sharing resource with this VM. They don't know that they are sharing resource with this other VM. They feel like they are the main, they are the main machine that is working on this particular server. So this is where it works. That way, memory usage can be better in the sense that by the time, let's say for example now, each VM uses 40 gig RAM, or let's say each VM uses like 25 gig RAM and let's say 6 CPU. So by the time you share 25 gig times 6 of them, so you have like 125 gig. So your resource usage is optimal. So this is the concept of virtualization. This is what virtualization came to do. So let me paste this here, and virtualization. This is what it came to do. But then, as technology would advance, there will always be one thing is that no matter what the technology that is rolled out today, it gets to a point where they will need an improvement. So there will always be something to improve on. Oh, we understood that. Okay, now because these virtual machines, they are basically like an operating system by themselves. They are heavy. They are heavy in terms of management, in terms of flexibility, in terms of movement. It's just basically saying, like, the issue that you have with, having 3 different operating systems, 3 different servers. It's heavy, and you can't move it from one place to another and all of that. It's just basically the same thing. The only difference now is that you now have a physical host or a physical server where you install a hypervisor on, and then you now have like different virtual machine, but all the virtual machine is still having the normal operating system. So it is still very, very heavy. It is still very, very difficult to move from one place to deploy. It's very, very difficult. And also in terms of booting, because it's a full operating system, it takes time to boot, it's slow and all of that. So this was looked into, and then we needed a better option. And then secondly, one thing that was observed is that most times, because of the difference in operating system, what works on a Windows operating system, an application that is if the developer writes an application on a Windows operating system, it's going to use the libraries and the dependencies of Windows operating system. So by the time you take that same application to a Mac OS or a Linux OS, you discover that it does not work. And that's why we always hear something like, we have an issue of it works on my system problem. So yes, as a developer, you're using a Windows operating system, you write an application, you install according to your operating system, it works. By the time you ship it out, people that use Mac OS, people that use Linux OS, they can install that same application and it won't work. Why? Because different operating system has different dependencies. They have different libraries. They have different way they work. So the architecture of a Windows operating system is different from the architecture of a Mac OS. It's different from that of a Linux OS. So that prompted the question. So we needed something that can work on all operating systems, regardless of your operating system. We need something that can actually work on it. That is also those 3 reasons is what brought about the concept of containerization. So with containerization, you package the application and all of the dependencies required to run that application. So now it is working with its own dependencies, the ones that you've configured it with it. So it's not taking dependencies from, it's not taking it's not using your base operating system library. It's not using the dependencies and all of that. So everything has been packaged as an image, something that we call an image. Yes. So when you create an image, you put everything that you need for the application to work. So with that image, all you need to do is just get a copy of the image and run it, and it's going to work. So that is how containerization came into the picture. So I believe I've been able to explain why containerization is very, very important. It helps us. And then secondly, because containers are actually, or will I say images or containers are actually not the full operating system. They are lightweight. They are very, very light. On a very good day, your backups and all of that, if you're doing that on your virtual machine, it could take gigabytes. But containers can basically just be like megabytes. It can be megabytes. And if you even want to make it really, really, really small, if you use the Alpine version of a container, it's extremely small. So they are very, very fast. They can be deployed fast, very, very fast. And also it's very, very useful when you want to do your CI/CD. And that is why this phase 2, I paired containers and CI/CD together, because they kind of work hand in hand in a way. So yes, so 2 reasons why containers came into play. One, to solve the issue of applications not working on different operating system. So everything is uniform. It is packaged into an image. That image contains everything that the application needs to run. All the information about the application that it needs to run is contained in that image. Then secondly, it is lightweight and easily deployed. You can easily deploy your containers in a production environment, and within seconds everything is up. As we progress in this phase, you will see how things are done, practically. So I just want to take my time to, talk about why there's need for containers. So by the time we understand this foundation, we can move into other things. So yes, we understand why containers came into play. Let's now streamline it to, we are going to be looking at Docker. We have several registries. We have Podman, we have Docker. Basically, these are containerization tools. So we have Podman, we have Docker. But in terms of popularity, and I think the most common is Docker. So it's just right that we consider Docker. So Docker is just will I say Docker is a tool, a containerization tool, that helps us package our applications into images, deploy them as containers, and just basically a tool for containerization. So all the things that we've explained as containerization, that is what Docker has actually come to do. So what then is a container? A container is a bundle of application libraries and dependencies that is required to run your application. I already explained that it has all the packages that you need to run your application. So you don't have to start looking for dependencies for Windows OS, for Mac OS, for Linux. No, everything is already packaged. It's just one bundle. It's just plug and play. Get the image, deploy it. That's all. You don't have to do so many things. So now let's look at Docker lifecycle. So Docker lifecycle is in 3 stages, or is in 3 stages. The first stage is, let me do this. The first stage is something we call, you create your Docker file. Then after creating your Docker file, you convert into an image, and then you convert to a container. So that is basically what Docker lifecycle is. I'm going to explain this. Also, we'll look at Docker architecture. When I explain the architecture, you're going to understand better. So first is, you create a Docker file. So what is a Docker file? Basically, a Docker file is like a set of, it contains the instructions, the manual that will be used to create the image. So that's what a Docker file is. It's as simple as that. It just contains, is a file that contains a set of instructions which we call it your Docker engine will use to create an image. So, and then that Docker file is created, is converted to an image using the Docker engine. So the Docker engine is what helps us to convert Docker files to images. So I'm going to, when I touch on the Docker architecture, I'll be able to explain about all of this. You will see what I mean by Docker engine and how everything works. So, but just hold this and keep it at the back of your thoughts. So if you ask what the Docker lifecycle is, Docker lifecycle basically is just where it's in 3 stages. You write your Docker file, it takes your Docker file, it converts that instruction to an image, and then after that it deploys that image as a container. So that is the whole summary of your Docker life cycle. It's as simple as that. Like I said, most of these things are just really simple and straightforward. It's not complex, it's not complicated. So now that we understand what Docker lifecycle is, to get a better understanding, we need to consider Docker architecture. So we are going to look into Docker architecture. So Docker architecture, the first thing you need to understand in Docker architecture is something that we'll call Docker host. So we have something called Docker host. So within this Docker host, most times this is where Docker host is basically where all your workloads is usually, being run. So in your Docker host, your workload will be run in your Docker host. Let me write it here. So we have Docker host. But Docker host uses something to, make all these things work. And then Docker host contains what we call your Docker engine. So remember I said Docker engine at one point. So we have the Docker engine, and the Docker engine has something that we call Docker daemon. So basically it is the Docker daemon itself that runs all of this process. So it's a running service. It processes, it provides an API access to be able to interact with it. So all of the commands that you want to write, basically it goes to the Docker daemon through the API access that has been provided. Let me write it, Docker daemon. Yes, Docker daemon let me put it in bracket. Docker D. Yes. So this is a running process. It's a running process. It provides API access so that any external client, we call it a Docker client. Yes, any client can communicate with it through the API access and send instructions to it. And then what it does is that it takes those instructions and acts upon it. So in the Docker host, we have about 4 things. We have the containers, we have container images, we have I think storage, we have network. But for this particular part, I'm going to just stick with 2 things, which is the container and the images. So I'm going to just follow with me as I try to explain. If you don't get this on the first instance, so you can always rewatch the videos again. So by the time you watch it, most times it doesn't usually sync on the first, when you hear it the first time, it will sound strange and all of that. But by the time you watch it over and over and over again, you begin to understand things better. And by yourself, I always say it, you can always go on your own and do further studies to get further knowledge. We are trying to cover this in 100 days, so definitely I might not be able to cover everything you need to know. Of course, DevOps is very broad. You can't actually cover everything in just a couple of videos. So it's left for you. You have to go back, and then if there are some parts that you feel like, the more you work as a DevOps engineer, the more things you see the need to actually understand. So by the time you encounter an issue, you go and research and add to your knowledge. What I'm doing here is making sure that you understand the basics, the foundation of DevOps. So with this and constant practice, you can, start working on projects. You can go for interviews, you understand, and, learn and all of that. So the more you keep working as a DevOps engineer, the more you keep seeing the need to get more knowledge about stuff. So, like I said, the API access provided by Docker daemon is used by, two. I said the Docker client. So let me go here and put this as the Docker client. This is Docker host. So basically I'm just trying to explain the architecture of Docker, and this is it. So we have the Docker client, and then lastly we have the registry. So we have the registry, or we call it hub. We have the registry. So we have various registries. It's not just Docker Hub. The ones we know, the one we'll be working with, since we're working with Docker, so we'll be working with Docker registry, which is Docker Hub. But we have more than that. Docker Hub. We have we have GitHub. We have GitHub container registry. That's GHCR. That's GitHub container registry. We have Amazon Elastic container registry. That's Amazon. That's for cloud, ACR. And then we have I think we have for Azure also. We have Azure container registry. So we have like quite a number of them. So these are registries. Basically, registries are like your storage houses for images. So most of the images that you would want to work with, there are some of them that have already been done beforehand, that have been created beforehand, and then all these images are stored in something called a registry. So what happens is that when you send an API call to your Docker daemon looking for an image, your Docker daemon goes to the registry that you've configured, looks for that image. If it gets that image, it pulls it for you, and then you can work with it. So let's like I said earlier, images are actually used to run containers. So you need an image of whatever application that you want to run. So for you to be able to run an image, for you to be able to run a container, you need an image. So I'm going to use let's say this is, come here and paste it. So this is, let's say these are images. So images are usually put in the registry. So we can have different images. We can have your Ubuntu image, you can have Nginx image, you can have Jenkins image, you can have so many images. So now to run an image, for an image to actually run an image, your Docker host needs to have a copy of that image. So there has to be a Docker, there has to be a copy of that image on the Docker host itself. And we can achieve this using two different ways. One, we can download the image. What do I mean by download the image? We can tell the let me put here. I didn't so we need Docker client. Your Docker client can be trying to make this Sorry, this is taking a while. So your Docker client can be your Docker CLI. That's one of your clients. Docker CLI is just basically like the command line interface for Docker. And then we also have Docker Hub. So Docker Hub is we also have we have Docker Desktop rather. Sorry, we have Docker Desktop. Docker Desktop is like the desktop version of your Docker. So those are like the two clients that usually interacts with your Docker daemon to make requests and all of that. Let me see. Will I cut this? Okay. Docker Desktop. So now I said that for an image to be run as container, your Docker host has to have a copy of that particular image. And I said we can do that in two ways. We can either download from the registry, or we create one and then send it to tell the Docker host or Docker daemon to use it to create a Docker image for us. So how do we do that? The first one, to download an image from your registry, we use a command called Docker pull. Docker pull. So your client, once you type your Docker pull, your Docker CLI sends, that's your Docker client, sends a pull, will I say a pull request? Yes. Makes tells your Docker daemon to go to your registry and pull an image, the image you desire. So what happens is that your Docker daemon now goes ahead, pulls that image, and brings the image to the Docker host. So that means your Docker host now has a copy of that image stored in something called Docker image. There's a command to check for that. When we start doing hands-on, we'll see all of this in full. And like I always say, this is for your Docker client to be able to talk to your Docker host. It talks to it through the API, which has been created by your Docker daemon. Basically, if you don't know what an API means, API basically is called Application Programming Interface, and it allows two things to communicate together. So basically, it fosters communication. So now there's a communication between your Docker client and your Docker host, specifically to your Docker daemon, because all of this process is actually run by your Docker daemon, which is your Docker-D. So your Docker pull, once you type Docker pull, is a command. Once you type the Docker pull command and the name of the image that you want, what is happening is that your Docker CLI is talking to your Docker daemon to go to the registry, that's your container registry, and look for that particular image. So if the image is present in the container registry, your Docker daemon will pull that image from the container registry down to your Docker host. Now, as at this point, your container is not running as an image. It's not your image is not running as a container yet. It has just gone to your Docker container registry and pulled that image, and it's already on your Docker host, but it is not running as a container yet. Now, that's the first way to have your image on your host. The second way is what I already said in this place. You create a Docker file. You create your own Docker file, that is your own copy of how you want your image to be. And then you use a command called Docker build. You use a command called Docker build. So with Docker build command, what happens is that your Docker CLI gives your Docker daemon this Docker file that you have created. Like I said, Docker file is a set of instructions which your Docker daemon will use to create or build an image. So basically, when you type your Docker build command, that's just the name. When you type your Docker build command, your Docker CLI presents this Docker file to your Docker daemon, and then your Docker daemon uses this Dockerfile to create an image of, that the way you've done it. So basically, that image, once you've created that image now resides on your Docker host. So those are the two ways for your Docker host to have an image. You're either pulling from your container registry or you're building one yourself using a Dockerfile. Now we have the images on our Docker host. So how do we turn these images to a container? You use a command called docker run. So when you send command, these are just there are other things attached to these commands. Basically, there are still some other options that you attach to this command, but these are like the building blocks. So by the time you type the docker run command, your Docker client will now talk to your Docker daemon using this API, telling it that, okay, you have an image on your host. I want to turn that image to a container. So what it does is that it takes a copy of that image and then turns it into a container, which is a running instance of an image. A container is a running instance of an image. The difference between an image and a container is that an image is just there. It's not doing anything. It's just an application that is not functioning, is not working. But by the time you type your docker run command, that image becomes a container, and containers are basically just running instance of an image. There's no big deal, there's no magic there. You understand? So now that's basically how your Docker host runs images. So Docker pull takes the container, tells the Docker daemon to go to the registry, pick out an image, and then it brings it to the Docker host. Docker build is when you have your own Docker file, and then you give your Docker file to the Docker daemon, and then tell the daemon to use the instructions in that file to create an image. And then Docker run now turns that image into a running instance, which is what we call a container. This is what is known as container. Now, let's assume now that you already have your own Docker file. You've customized your image in a way that you want it to be customized, and then you've tested everything, it's working and all of that. Now you want to make that image public. You want other people to be able to access this image and then deploy it to their own systems. What do? You have to tell Docker daemon to send that image to your registry. And how do you do that? You use the command docker push. So when you use the docker push command, you're talking to your Docker daemon and telling the daemon that, okay, this image that you have built for me, send a copy of it to the registry so that it can be accessible to anybody. So for example, now you can push your image to Docker Hub. When you push your image to Docker Hub, I can go to Docker Hub. If I search for the name that you've given to that image, I will see the image and I will be able to pull that image to my host. I will be able to run that image, and it's going to work exactly the way you have configured that image to be. So basically, this is the whole architecture of Docker. Let me write this. Docker architecture. So basically, this is the whole architecture of Docker. Your client makes a request to your Docker host, which is handled by your Docker daemon, and then the Docker daemon executes the request based on what the request is. Your registry is like a storehouse for your images. Your Docker daemon interacts with both your registry and your Docker client using the APIs that it has provided. So that's just like the whole concept or the whole architecture of Docker. So I hope I've been able to explain well. So now we've covered why we need containers. We've covered container lifecycle, that's Docker lifecycle, and we've also been able to extensively look at Docker architecture. So the last thing we are going to do before we call it a day is to set up Docker. So we are going to go, this is where we'll do a little bit of hands-on and we'll be able to set up Docker on our virtual machine. So we have our virtual machine here, the same one that we have been using since the beginning of this particular journey. So how do we install Docker on our virtual machine? So we just come here and we'll do install Docker. So one thing we always have to do is always refer to in documentation. Most of these tools have documentation, and the best way or the best place to actually look to do things is the documentation, because documentation will always be up to date. So there are two ways we can install Docker. We can either install Docker desktop if you're using a Windows operating system. Like for me now, I have Docker desktop. When I type Docker desktop, when I type Docker, you can see I have Docker desktop here. So you can install Docker desktop on your Windows operating system. If you're using Ubuntu, which is what I'm using, you click on Ubuntu and then you scroll down, you'll see the instructions on how to install it. So the first is Docker engine depends on containerd and run C. Docker engine builds these dependencies, blah, 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 blah. So if you have installed containerd, blah, 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 basically this is just if you have installed some things previously that you're not sure about, maybe the latest you've installed old version or everything, it is just better to run this command. Run this following command to uninstall all conflicting packages. So this is what you do first. We come to our terminal, we run the command, and we type in the password. We wait a sec for the command to finish running. So it's going to check all of this. So that is done. Then the next step, so once that is done, we can now go into the installation method. So they said step 1, we run this command. All of it, so it's just copy. You copy it, you come here, you paste. So you run the command and it's going to start executing the command. So we're going to give it a sec for it to finish running. So you can see here that there's something sudo apt get update. So you always have to run sudo apt update whenever you're trying to do a fresh installation, because you need to update your repository and be sure that everything that you have there is up to date. So whenever you want to install a package, you always have to run sudo apt update. So now our command is done. The next thing is we are going to, so the first thing is you set up Docker apt repository. Step 2 is to install the Docker package. So we are going to use this command to install the Docker package. So let me clear again, and then we'll install the Docker package using this command. We just type Y or press enter. Once you see capital Y, it means that the default is yes. So you can either choose to type Y or you just press enter. If you see this no is capitalized, it means that the default is no. So you can, if you want it to be yes, you have to now type yes. So for me, I'll just press enter. So it's going to continue installing, and let's give it a moment. So after that, we need to verify. This is actually an application that tests if Docker is working. So we're going to copy this and come back here. Just give this a moment for it to finish installing. So I'm going to pause the video here and I'll be back once installation has been completed. All right, that took a while, but installation is complete. So let's run the command sudo docker run. Like you can see now, I'm using the command docker run. So what docker run will do is that docker run can actually do two things. What docker run does is that docker run checks your Docker host, that's your system, if an image is the image is actually there. So if it's not there, it goes to pull the image from the container registry. The difference between Docker pull and Docker run is that Docker pull will just pull the image from the registry down to your Docker host, but it will not run it. But Docker run will do two things. If the image is in your Docker host already, it will run that image. But if it is not in your Docker host, it will first go pull the image from the registry and then run that image on your host. So when I do Docker run hello world, it will say unable to find hello world locally. That means that image is currently not on my host. So what we will do now is that you now see pulling from this. So it's going to the registry to go and pull that image. So you can see hello from Docker. This message shows that your installation appears to be working correctly. So now it shows that we already have our Docker set up. So that's the process of setting up your Docker. So let's do something quick before we go. Basically, we've done everything we want to do in this video. Let's quickly pull an image and then we'll see how we can access that image. So let's do sudo docker. I'll also do run because I don't have that image, but I don't want to go through the stress of pulling and then running. So let's pull an Nginx. Since we covered Nginx yesterday, I will also show you that there's an image of Nginx that we can actually pull. So we can do sudo docker run Nginx. So when I press enter, it will say unable to find Nginx locally. Obviously, Nginx, I've not pulled that image. So now it's going to pulling from library and all of that. So let's wait for this to complete. So the image is 28 point okay, the image is not 28.23, it's just the libraries and all of that. So let's wait for it to finish pulling. I made an error. I'm supposed to pull the image before running so that I can be able to map it to a port. But well, that's still okay. That's still okay. I can always stop it. I can always stop it. This is actually beyond the scope of this first session, but I would still try and get that done regardless. Okay, I think this is actually taking time. So basically what we've done today is I think we can actually, this is a good point to actually call it a day here. We've been able to understand what containers are. We've been able to talk about the Docker lifecycle, Docker architecture, and then we've been able to set up Docker on our virtual machine. So this is actually a good place to call it a day for now. We'll continue with this progression. We're going to see more commands. We're going to be able to do a lot of commands tomorrow as we progress. So I will see you again tomorrow. So enjoy the rest of your day. Cheers.